if one of the best places for life in the galaxy is a planet that has never seen a sunrise? Not a world blessed by a warm star. Not a blue planet with seasons and skies. A black, frozen, rogue planet, drifting between suns where daylight may never matter at all. That sounds impossible. Life, at least in our instincts, belongs to sunlight, to photosynthesis, to orbit, to the comforting idea that warmth must come from a star overhead. But astronomers have spent the last few decades sketching a stranger possibility. Under the right conditions, a starless planet could trap enough heat to keep an ocean liquid beneath the dark. And the thesis of this story is unsettling. Some of the loneliest planets in the Milky Way may not be dead failures of planet formation. They may be insulated survivors. In a few cases, they could even be more stable hiding places for life than many planets clinging to dangerous stars. The idea goes back in part to a 1999 paper by David J. Stevenson at Caltech. Stevenson asked a question that still feels almost rude to common sense. What if a planet ejected into interstellar space could hold on to a thick hydrogen atmosphere and keep surface temperatures high enough for liquid water? Not because space is warm. It absolutely is not. Interstellar space sits near 3 Kelvin, barely above absolute zero. 3. That is colder than anything your body can really imagine. Yet, a planet does not need much internal heat if it is wrapped in the right blanket. Think of a thermos in a blizzard. The blizzard is lethal. The insulation is the whole story. On Earth, our average geothermal heat flow is tiny compared with incoming sunlight, roughly 0.09 watts per square meter. By itself, that sounds hopeless, a weak planetary fever. But hydrogen changes the math, because at high pressures, it becomes an exceptional greenhouse gas through collision-induced absorption. In plain English, hydrogen molecules that normally interact weakly with infrared radiation start trapping heat effectively when packed densely together. So the what is simple. A rogue planet is a world no longer orbiting a star. The how is more surprising. If that planet is several times the mass of Earth and carries a thick hydrogen atmosphere, its own leftover formation heat plus radioactive decay inside the mantle might be enough to prevent total freeze-out. And this is where the story gets uncomfortable, in the best way. We tend to call these worlds homeless. But what if a star is not always a home? What if for some planets, a star is a hazard? Many stars are violent. Red dwarfs, the most common stars in the galaxy, can blast nearby planets with flares, ultraviolet radiation, and charged particles for billions of years. Proxima Centauri, for example, has produced super flares far stronger than typical solar events measured on Earth. TRAPPIST-1's planets may be intriguing, but they also live in a system where space weather could batter atmospheres relentlessly. A planet in darkness sounds tragic. A planet welded to an unstable star may be worse. Personally, this is where the idea stopped feeling like science fiction to me and started feeling almost philosophical. We have a built-in bias toward light. We assume visible means alive, and dark means dead. The universe has never promised that. astronomers think rogue planets may be common.
In 2011, a nature study led by Takahiro Sumi used gravitational microlensing and suggested Jupiter-mass rogue planets could be extremely abundant, possibly comparable to or exceeding the number of main sequence stars, though later work has refined the estimate and increased the uncertainty. Then, in 2023, observations from the James Webb Space Telescope found free-floating Jupiter-mass objects in the Orion Nebula, adding fresh weight to the idea that starless worlds are not rare cosmic accidents. If even a small fraction of those objects are smaller rocky planets rather than gas giants, the arithmetic gets wild very quickly. Could the galaxy be filled with hidden oceans no telescope can easily see? Could life be drifting past us right now, inside a globe of black ice and compressed air? Oh, I want your take on this before we go deeper. Do you think a planet without a star sounds more promising for life? Or less? Pick one and tell me why in the comments. There is another twist. A rogue planet does not need a perfectly Earth-like ocean exposed under an open sky. The more realistic picture is harsher and somehow even more compelling. A frozen outer shell, maybe kilometers thick, with a buried ocean underneath, protected from vacuum, radiation, and the chaos of nearby stars. We already know hidden oceans are not fantasy. Europa almost certainly hides one. Enceladus sprays water-rich plumes into space. Titan has a thick atmosphere and complex chemistry on the surface. None of these moons depend on sunlight in the simple way Earth does. They rely on tidal heating, chemistry, insulation. The rogue planet idea takes that logic and removes the star almost entirely. And the chemistry matters. Life on Earth may have begun around hydrothermal systems, where chemical gradients, not sunlight, did the heavy lifting. In 2016, a study in Nature Microbiology argued that Luca, the last universal common ancestor, likely lived in a hydrothermal environment rich in hydrogen. That does not prove life begins easily in the dark, but it does weaken the old intuition that sunlight is the only serious engine. The hidden advantage of rogue planets may be time. Stellar systems change. Stars brighten, flare, destabilize climates, and eventually die. A well-insulated rogue world could be geologically quiet, chemically persistent, and dark for eons. No sunsets, no sunrises, but also no stellar tantrums stripping away the atmosphere. Stability can be a form of kindness. That does not mean these worlds are easy places for life. Far from it. The atmosphere could be crushing. The surface could be lethally cold. Photosynthesis, at least as we know it, would be nearly absent. Any biosphere would likely be microbial, buried, and alien in metabolism. You would not walk there under a black sky and call it paradise. It would be more like an ocean bunker built by physics itself. But wait, there is a detail that shifts this from weird possibility to serious target. Rogue planets might actually be easier to keep habitable than some planets inside the so-called habitable zone. That phrase sounds comforting, but it hides a mess. A world can sit at the right distance from a star and still be sterilized by flares, lose its atmosphere, enter runaway greenhouse conditions, or freeze from orbital chaos. Distance alone is not habitability. Protection is habitability.
That to me is the disturbing part. We may have romanticized sunlight because it comforts us, not because it is always optimal. If you were a microbe choosing between a turbulent world under an angry red dwarf and a chemically rich ocean sealed inside a dark hydrogen cocoon, what would you choose? Recent work is also pushing astronomers to think harder about detection. In 2021 and 2022, multiple teams using microlensing surveys reported evidence for free-floating, roughly Earth mass candidates, though the exact population remains debated. We are still looking through a keyhole. Still, every improvement in infrared astronomy and microlensing statistics makes the invisible population feel less hypothetical. Confession. When I first read Stevenson's old argument, I assumed the catch would kill it. Maybe hydrogen would escape too fast. Maybe ejection would strip everything away. Maybe the numbers would collapse. And yes, there are huge uncertainties. Retaining a thick hydrogen atmosphere is much easier for more massive planets. Formation history matters. Impact history matters. Internal heat fades over time. But the idea survived serious scrutiny long enough that scientists never quite let it go. That alone is telling. In astronomy, bad ideas usually die loudly. This one keeps whispering. And honestly, just that possibility is worth a like. A planet with no sunrise may still have an ocean. If that surprised you even a little, hit like, because the final implication is the one that really stays with you. The payoff is bigger than one strange class of worlds. It changes the emotional map of the galaxy. We usually imagine life as something that clings to narrow coastlines around stars, tiny islands of biology in a mostly dead sea. Rogue planets suggest a darker possibility. Life may not need the lighthouse. It may prefer the cave. If that is true, then the Milky Way could be full of inhabited places that never glow, never transit a star, never send us easy atmospheric signals. Worlds with oceans under pressure, chemistry in silence, evolution with no dawn to mark the days. And there is something humbling here. We built our sense of habitability from one example, Earth. Blue sky, yellow sun, liquid water on the surface. A lovely sample size of one. The universe may be under no obligation to repeat our favorite design. Maybe the lesson is not that life is fragile. Maybe it is that life, when given even a small pocket of energy and enough time, becomes offensively hard to erase. I think that is the most beautiful and unsettling possibility in this entire story. So the next time you hear the phrase homeless planet, listen carefully. That world may not be homeless at all. It may be sealed, hidden, and enduring in ways that bright planets are not. A frozen shell on the outside. A living question underneath. If the universe feels bigger to you after hearing this, subscribe. This channel is for people who like having their sense of what is possible stretched far beyond the obvious.